All right, so we're going to go over section 6.1 and 6.2 today because this is all review of stuff from Algebra 1 for the most part. So we're going to be talking about roots and rational exponents. Okay, when I talk about a rational number, does anybody out there know what I mean by a rational number? Part of the word right here, ratio. Okay, a rational number is any number that can be expressed as a ratio or a fraction. Okay, irrational is like pi. There's no repeating. That's irrational. And irrational would also be like the square root of 2. There's no repeating decimal or anything like that. But if you have a repeating decimal, or it can be expressed as a fraction, or if it's an integer, it's a rational number. Okay? So when we're talking about rational exponents, we're going to actually have fractional exponents. So something you should have seen before, but probably need your memory refreshed, I'm thinking. Okay. So when we're talking about real roots, this little number out in front here, that 4, that means we're taking the 4th root. That's called the index, just if you want to know what that thing's called. And so when you take the 4th root, basically you're asking yourself what number times itself 4 times is going to equal what's under the radical. In this case, 10 to the 4th, or 10 times 10 times 10 times 10. So the 4th root of 10,000 would just be 10. When you're taking odd roots, like a 3rd root or a 5th root, if you're taking odd roots, then you're going to have one real root. It's either going to be positive or negative. Because suppose I have the 3rd root of negative 27. What number multiplied 3 times is going to give us negative 27? Negative 3. Okay? Would positive 3 to the 3rd ever give us negative 27? No. So that's why when it's an odd root, you only have one real root that's either positive or negative. Okay? However, if it's an even root, then you have 2 real roots. It would be the positive and the negative. So, for instance, up here, this could have been negative 10 times negative 10 times negative 10 times negative 10. So really, my answer should have been plus or minus 10 on that one. Okay? Alrighty. So let's do some examples. So for example 1, we're going to find the indicated nth root of a. So most of these you can pretty much guess and check because their numbers aren't very huge. So what I'm doing on letter A then is I am going to take the 3rd root of negative 216. So is my answer going to be positive or negative? It's going to have to be negative. And so I know it can't be 4 times 4 times 4 because that's 64, and it's certainly not going to be 5 times 5 times 5 because that's 125. And if I check 6 times 6 times 6, it does come out to 216. So this is essentially negative 6 times negative 6 times negative 6, and so it equals negative 6. So on your homework, you don't necessarily have to show that in between step, but you should at least write the problem down and your answer. And so this one was odd. We had just one answer. But on the next one, I'm going to take the 4th root of 81. So what number times itself 4 times do you suppose is going to equal 81? 3, yeah, but it could be plus or minus 3. Okay? So again, when it's even, then we're going to have our plus or minus, okay, and have 2 roots. So here's one for you guys to do on your whiteboards. Okay, so it's an even root. It's plus or minus, and looks like you guys all got 5. All right, how about this one? All right, so do we all agree -4? Yes. Okay. So fractional exponents. If a number is raised to a fractional exponent, what you need to remember is this top one is the power, and the bottom of the fraction is the root. And so there's a couple different ways you could rearrange that. It means I'm taking the nth root of x, and then I'm raising it to the m power. Or you could also look at it as the nth root of x to the m power. So typically, you're going to use this first arrangement when we're talking about numbers, and the second arrangement when we're talking about variables. Because with numbers, it's easier to take the root first, get a smaller number, and then raise it to a power. If you raise it to the power first and then try to take the root, that makes it more difficult. All right, so we're going to evaluate 16 to the 3/2 power. So that means I'm taking the square root of 16, because remember, when we take a square root, it's the second root. We just don't usually write that 2 there, okay? So keep that in mind. When we're taking a square root, the index is actually 2. It's just assumed, and we don't usually write it. So I'm going to take the square root of 16, and then I'm going to raise that to the 3rd power. So that would be 4 to the 3rd power, which is 64. So you guys go ahead and see if you can do the next one. It's kind of tricky, though. Maybe tricky. All right, so looked like most of you were getting 32. Do you guys agree? Okay. And here's another one. Now this time it's being raised to a negative power. So what's that mean when I have a negative power?
It's going to be a negative?
It's not going to be negative, no. What do I have to do? Flip it, yes. Okay. All right, so now we've got 1 over 32 to the 3/5, because after you move it, you make it a positive exponent. So that means I'm doing the 5th root of 32, which you guys should know based on the problem directly above. And then we're cubing it. So what is the 5th root of 32? It's 2, right? Okay, yes, hopefully you noticed that's the problem right above. So now we've got 1 over 2 cubed, or 1 over 8. All right, so you guys do this one on your whiteboards. All right, so most of you are coming up with 1/3. Did anybody have a question where the 1/3 came from? No? Good? All right, then moving on. Okay, so now we can use the roots to solve equations, so don't worry about the whiteboard ones yet. Okay, so if I have 4 times x to the 5th equals 128, I can divide both sides by 4. And then I have x to the 5th is equal to 32. And you guys all know what the 5th root of 32 is, right? So x would have to equal 2. Now, could it be -2? Not in this case, because it's a 5th root. Right, so it would just be 2. Okay, so you guys get to do this one. What's the opposite of multiplying by 1/2? Multiplying by what? 2, yeah. So if you multiply by 2, you can undo it. So, multiply by the reciprocal, that's right. All right, so are we agreeing that x is equal to 4?
Yeah.
Okay, now if you want to know how you could have like a shortcut to check that with your calculator, instead of doing 4 times 4 times 4 times 4 times 4, do you guys know about the caret button? The caret button, it looks like this. That's called a caret.
Why?
I don't know why it's called a caret, but it is. So you could put in 4, hit the caret button, put in 5, and that'll give you the 1024. Okay? So you can raise a number to any power using that button. All right, so here's another example for your notes. We've got x minus 3 to the 4th power equals 21. So I'm going to take the 4th root of both sides. And so I get x minus 3 is equal to the 4th root of 21. Now, can I figure out what the 4th root of 21 is? No, I can't. So I'm just going to leave it as a radical, and that's what you guys should do on your homework. If you run into any that you can't, it's not a number that you can actually figure out, just leave it as a radical. Am I done, though, with this problem? No, what do I have to do? Add the 3, yeah. So I get that x is equal to 3, and then because it could be positive or negative, it'd be plus or minus the 4th root of 21. Okay, so this should be a plus or minus over here. All right, so here's one for you guys. Okay, so some of you are having a little bit harder time with this one. If I take the 4th root of x plus 5 to the 4th, it's just x plus 5. And what did you guys decide was the 4th root of 16? Plus or minus 2, right? Okay, so a lot of you were getting to this point just fine, and then you didn't know what to do. That's just two numbers. It's negative 5 plus 2, and it's negative 5 minus 2. What is negative 5 plus 2? Negative 3. What is negative 5 minus 2? Negative 7. Those are your answers. Okay? You just have to finish doing it all the way. All right? Okay, so 6.2 goes on to apply the properties of exponents. So if you haven't memorized those properties yet, now you're going to need to know them by heart, because you can't really do this by writing it out the long way. You really have to know the rules. So, for example, in this first problem, I've got 7 to the 1/4 times 7 to the 1/2. So when I have two powers that are being multiplied together, who remembers what we do with the exponents? You add them together, yes. So we would have 7 to the 1/4 plus 1/2. What is 1/4 plus 1/2? 3/4. So your answer would be 7 to the 3/4. So we use the same properties just like we did when we had whole numbers or integers, rather. You just add them when you're multiplying. Okay, so for the next one, I've got two powers being multiplied, but then they're being raised to the second power. So when a power is raised to a power, then what do I do with the exponents? What am I going to do with the 2 and the 1/3, say? I have to multiply them now. So I'm going to have 6 to the 1/2 times 2 times 4 to the 1/3 times 2. So 1/2 times 2 is just 1, right? So 6 is just to the first power. Do I have to write the 1? No, it's assumed. And then times 4 to the 2/3. And that would be your answer. You would just leave it in that form. Okay, and when we have a negative exponent, that means I flip it. But I notice on the inside, I've got 4 and 3 are both being raised to the 5th power. So I can actually simplify inside if I want to first. I could say that it's 4 times 3 being raised to the 5th power, and then the whole thing is being raised to the negative 1/5. And so if I multiply my exponents together, negative 1/5 times 5, that's going to come out to negative 1, right? And then 4 times 3 is 12. So now I've got 12 to the negative 1 power, and so that's 1 over 12. Okay. When we have a quotient, instead of adding our exponents, what are we doing? Subtracting, right? We're taking the top and subtracting the bottom with our exponents. And if I have just a 5, what do I assume is my exponent there? A 1. So what this really is 5 to the 1 minus 1/3, or 5 to the 2/3 power. Okay, so now I've got 42 and to the 1/3 power divided by 6 to the 1/3 power, and then the whole thing is being squared. So again, if you have two things being raised to the same power, you can rewrite them. I can rewrite it as 42 over 6 being raised to the 1/3 power, and then the whole thing is being squared. So what is 42 divided by 6?
7.
It's 7. And then I do 1/3 times 2, and I get 2/3. So that would be 7 to the 2/3 power. All right, on this one, the 5 on the bottom is being raised to a negative 1/4, isn't it? So what do I have to do with that 5? I need to move it up to the top, right? Okay. So if I do that, then I have 80 to the 1/4 times 5 to the 1/4. So that's just 80 times 5 to the 1/4, or 400 to the 1/4. So now 400, that's something I can actually break down. 400 is, well, the 80 was 5 times 16, which is 5 times 2 times 2 times 2 times 2, and then the other 5. So essentially, I'm taking the 4th root of 2 to the 4th times 5 squared, right? You guys follow that? Or another way of looking at it. Okay, do you know where I got the 5 times 2 times 2 times 2 times 2? That's the 80, right? Right here is the 80. And then I have the 5. So I've got 2 to the 4th times 5 squared, and I'm raising that to the 1/4 power. So I'm saying instead of multiplying it out, you might want to factor it so that you can figure out your powers, and you can simplify it down more easily. So 1/4 times 4 is what? What's 1/4 of 4? 1. So I have 2 to the 1st power, right? Yes. So do I have to write the 1, Oscar? No, I don't have to. But can I if I want to? Yes. Okay. And then your 5 is going to be 1/4 times 2. So what is 2 times a quarter? If you have 2 quarters, how much of a dollar do you have? Half of it. Okay, so that would be your final answer on that one. Okay, so here's one for you guys to do. I've got a few of these for you. Okay, so we came up with 5 times 7 to the 3/4. Here's another one for you. Okay, so what's 3/4 plus 1/2? 5/4. So we have 2 to the 5/4 power. You could technically say it's 2 times 2 to the 1/4 if you wanted to. Either way. Okay, let's do this one now. Okay, so it's like we have 3 to the 1st up here, so it's 1 minus 1/4. So 3 to the 3/4. Okay. All right, so using properties of radicals. Okay, so when you get to these, rather than getting a big number, another way of looking at it is to break it down into like a prime factorization. So like your 12 is going to be 2 times 2 times 3, and 18 is 2 times 3 times 3, right? If I break it down. So when I put them together, I'm taking the cube root of 2 cubed times 3 cubed. Did everybody follow how I got there? Okay. And so the cube root of 2 cubed is just 2. The cube root of 3 cubed is just 3. So the answer is, and it would be plus or minus, oh no, plus or minus, my bad. It's just positive 6, yeah. Okay, so you guys get to do this one on your whiteboards. If they're both being, oh no, you're not. I'm going to do this one. I take it back. Okay, they're both being raised to the 4th root. So that means that I can actually put them together as a fraction under one radical. I can take the 4th root of 80 divided by 5. And so if you divide 80 by 5, you get 16. And so the 4th root of 16 would be plus or minus 2. So now you guys get to do one. I'll have you do this one first. It's plus or minus because it's an even root. Because I could do negative 2 and raise it to the 4th power, or positive 2. And either way, it would come out to a positive 16. Okay, so we agree plus or minus 3, right? Okay. We can do the same thing when we have variables. Essentially, all you're doing is you're taking and going the opposite way. So remember when we had x to the m over n, that was our power, and that was our root? Well, we can kind of do the same thing going the other way. First of all, I could take the 3rd root of 64. 64 is 4 times 4 times 4. So that's going to be 4. And then I've got y to the 6th divided by 2. Or another way you could look at it is basically y to the 6th is the same as y squared to the 3rd, right? Either way, if I take the cube root of it, I end up with 4y squared. If it didn't work out evenly, though, suppose that I had taken, actually I wish they'd had an example like this, but I don't think they do. Suppose I was taking the 4th root of y to the 5th power. What do you guys think I should do then? No ideas? Could I break that down to y to the 4th times y? I could. And so then I'd be able to take the 4th root of the y to the 4th. I'd have that on the outside as just y. And then I'd leave the other y underneath. Okay? So if you end up where it doesn't divide out evenly, you just take out what you can and leave the other stuff under the radical. Okay? B, it's the same thing as we were doing before. You're just going to multiply the exponents. So I've got 27 to the 1/3 power, p to the 1st power, and q to the 4th power, because 1/3 of 12 is 4. And so the cube root of 27 is 3, p, q to the 4th. Okay, I'm going to move on in the interest of time. So with radicals, we've done this before again. You just add and subtract your like radicals. So A and B are really obvious because everything's the same. But I'm going to look at C here because I have different numbers under the radical, or so it seems. But if I take 54 and I break it down, it's actually 2 times 3 times 3 times 3. So I've got the cube root of 2 times 3 cubed minus the cube root of 2. So I can take that 3 out. Now I've got 3 times the cube root of 2 minus the cube root of 2. How many cube root of 2's do I have left? Well, we assume that there's a 1 out here, right? So 3 minus 1 is 2. So it's 2 times the cube root of 2. Okay? And I think that's most of what you guys need to know. If they want it in simplest form, you do need to look to see if anything divides into it. So in this case, it breaks down to 3 times 3 times 3 times 5. And so when you take the cube root, you just have 3 times the cube root of 5 after you simplify it. And then one more example with the radicals. I know we're running short on time, so I want to make sure I give you this one. Okay, so this is what I was talking about before, where not everything's going to divide evenly. I can't take the 5th root of 4. That's just going to stay the way it was. But my a to the 8th, I can think of that as a to the 5th times a cubed, right? And my b to the 14th could be b to the 10th times b to the 4th. And then the c to the 5th, I'll just leave it. So I've got a to the 5th, b to the 10th, and c to the 5th that I can take the 5th root of, right? And so I can take those outside of the radical. And so now I've got an a b squared, because 10 divided by 5 is 2, and a c on the outside. And then left on the inside, I have 4a cubed b to the 4th. Okay? So, so again, this is review from Algebra 1, although in Algebra 1 you probably didn't get problems that were quite this complicated, but still you're just doing the same thing. You're adding and subtracting, you're multiplying when it's a power to a power, you're using all the same properties, it's just now we have some fractions involved, okay? I will be in here at lunch today if anybody needs to come in for help.